Ladies and gentlemen, it's my honor to come here to share my research. I'm Zhang from Beijing Normal University, Beijing, China. My research is about greenhouse instance mapping at large scale using remote sensing technology. There are considered 4 parts. As we know, AI technology is very popular. I think there are 3 breaking events about the AI technology development. The first one is the AlphaGo. It's a very powerful game on Go, which have won the humans in 2016. And the second one is the ChatGPT. As we know, ChatGPT is very popular in these years. We can talk with the computer, and the computer can give a recent and very useful information quickly. And the third one is the segmentation, everything as we know. When we look at something around the Earth, and this object is very complex, and so we segment the image into the every part what you want. This is the powerful and the AI has gave us. So information is the foundation of the scientific decision making. And so we need to use the AI convert the data into the information. And this is AI has the basic to run. The first one is a large amount of data, and the second one is computing power, and the third one is the algorithm and the models. So from this base, and we can convert the data into the information automatically. And in my presentation, I will focus on introduce the AI in the remote sensing field. Remote sensing field AI has been used in the remote sensing field widely. The first one is object detection. Look at the pictures. Look at the pictures, and from these pictures we can locate the shapes, the buildings, the aircrafts easily. And the second one is the image segmentation. It's very useful and very useful. Here we can count how large areas have planted in such areas, and so we can use this as a crowd mapping. And and third one is the instant segmentation. This is the purpose of my research box. Look at here. Sorry. Look at here. Look at here. Is a remote sensing data. It's a high resolution data, and from data we can convert this image into the instance of the greenhouse. Okay, let's continue. The second part is the digital greenhouse in China. Greenhouse is very useful, and it can supply the food sharing, and it's a local environment, and control the solar energies, and the pesticide controls and water controls. It can make optimize the environment to supply the crop grow well. So, and in my research, in my studies, I try to convert the remote sensing into the individual's instance on greenhouse. And in order to help to agriculture planning, policy making, production monitoring, and in order to also promote technology. Recently, there are some research about how to extract the greenhouse. Look here is a research in China. There's in these studies, it trains the models in the several places and try the models into the whole countries. And this here is the final result. And in this research we can count how large areas have covered in the every province. And for this research, I found there are some issues about it. The first one is it's difficult to obtain greenhouse individuals instance in the sense of a dense greenhouse area. And the second one is the poor recognition, in fact, after large-scale spatial migration of the model. Look here, if the greenhouse is dense and it's hard to, and in this one, and it's hard to classify the individual instance. And the third one is my studies and how to solve the problems. And look at here. We need to redefine the greenhouse instance definitions. Look at this. The greenhouse is is consisted of two parts. The first part is the region. Is the area which covers the ground, and the second one is the boundary, and the region and plus the boundary is equal to the distance. So this is the definition. We need to train the models to define the two parts. So we need to answer the two questions. The first one is how to extract the greenhouse instance based on AI. This AI is the way we use the technology. This question we need to answer how to accurate to extract the greenhouse. And the second one is how to extract the large-scale greenhouse instance. That means we need to transfer the models into the other place from the basic areas and to transfer the model into the other area into the large countries. Okay, next is the data we used. We have the 6 areas, and for the in the areas is the Shouguang province, and in Shouguang, Shandong province. And this is the basic areas we train the models in this use this area data. In these areas, we have more than 15,000 sampling, and the validation data is about the 500 sampling, and the test data is also about 5,000. And also we test the data. We migrate the data into the other place in the rest file place here is and the rest areas is in the Liaoning province, and the Zhejiang province, the Hubei province, the Yunnan province, and also the Xinjiang province. This is a big area, and this migration area. So in the basic areas, this Shouguang province, Shouguang in Shandong province, from this study areas we can say there's a dense landscape on the sparse landscape in such areas. Look here is the sparse in this areas is the denser. So this is the flowchart on my study. The first part is the training data production and how to build the label data set. And the second one is the identification and update on greenhouse region and boundary. And this we separate the greenhouse in two parts. That is the region and boundary. And second part is the post classification is the refining vector expression on recognition results. And also, the fourth step is to transfer the model into the other place. The final step is to accuracy elevation. Compared to the traditional methods is just compare the the greenhouse and the background as two parts. And in my studies, I convert the greenhouse into three parts. The first part is to the background, and background that is not greenhouse. And the second part is the boundary regions. In this part, we can define the regions which covers ground, and and third part is the label boundaries that is enclose the greenhouse. And then we train the models. Train this. This is a supervised classification. And here is the very important step is to how to define the focal loss. Here is the focal loss. How we can define and finally we convert the image into three parts: background, region, and the boundary, and then and finally the greenhouse greenhouse case was extracted. Here, we compared four networks. That is the PSP-net, deep lab with 3 plus HRNet and the UNet. Here the advantage and the shortcoming about the networks. Here is the experimental parameters, which includes the learning rate, batch size in epoch, and this is a very simple, very to similar the four parts, the full network, and here if we have trained the models and convert the image into the very useful information about the greenhouse, this is a raster format, and we need to further post classifications that including domain analysis, expansion, and try to rectangles the rectangleize the case into the final results. Oh, this is the post classification process. Is the boundary removing and the domain expansion and minimums. That's rectangles. And from these three steps, and we can get the greenhouse instance accurately. Oh, this is the precision evaluations matrix. Include precision, recall, and F1 and IOU. Oh, this is in the four networks we have found that the UNet is the best and has the highest accuracy. And after training more than 6 epochs, the loss on UNet also is the lowest among the full network. Here is from the network we compare the UNet and the other 3 networks. And from the UNet we can extract on mapping the greenhouse instance accurately, and this compares between the PSPNet and the UNet, this UNet and DeepV3, and UNet with HRNet. And we can find the UNet can get the satisfied result. And then, in the next step is we compare the our studies and with the conventional or traditional method. And from this method, we look at the final result. And in this part, there's a lot of greenhouse cases in this area, but the traditional method convert one group. In our method, we can set it separate by our method. We can get a conclusion that our method is good, is better than the traditional method. And also, we transferred our basic models into the other place. And in this area, and also we test the three three settings. The first setting is to we direct our basic models into the other place, and also other place. And the second one is we test the scale adjustment. As we know, even greenhouse, which covers on the Earth, on the land surface, but the landscape is various, such as, for example, in the Shandong province, the greenhouse is very large and very large. But however, in the Yunnan province, the greenhouse may be small, But if we train the models in the Shandong province, when we transfer the models into the Yunnan province, maybe it's not good. So we also test the scale adjustment. And the third is the scale statement, and also use the small samples to fine-tune our models. And from this, the final step, we introduce the local samples. Is 14.6. Here, we at beginning, and we test the scales, to find the principle how the scales influence affect the training model. And we test the 0.3 and 2 the 2.1 meters. And here we in the greenhouse greenhouse is different in the different scales image. And also we found that if the greenhouse is from the 9.4 to 21.8 meters, is the number on the pixels. It consists on the 8 to 18 pixels. The accuracy has option is highest. So we can conclude, and we can summarize that formula as the image is resolution. The image size is about from this formula. And if we transfer the models into the other place, we can calculate how large size in this area. And we also impose the greenhouse size into the formula, and then we can get how image spatial resolution to be used. And here we transfer the models we transform into the other place, and there's three modes. three modes. The first mode is the direct migration based on Shouguang models. Look here is if we transfer the models into the other place, and we find the recognition effect is this is a result. This is a result, and this is a vectorized, and the instance on the greenhouse is extract. However, if in the Yunnan province, in the Liaoning province, the greenhouse cases is good. However, in the Yunnan province, the effect is not good. This is depend on the scale. We guess this depend on the scales because the greenhouse in Yunnan is totally different from the Shouguang area. So in the second mode, and we transfer the model into the other place after scale adjustment. Look here, there's look here in the Yunnan province, and from the previous slide, we can find that the Yunnan province, in the result of Yunnan province is not good. And in this slide, we can tell after the scale justifications, and the result is better. And it's depend. So we can get a conclusion that the scale influence the result. And furthermore, and we transfer the third models, the new models migration out the skill justification with some new training labels are input into the model to fine-tune the model. And from this model, we can that in the five areas, and the final result is the most all satisfied. So this is this process is very useful to get the greenhouse instance. Oh, okay. Here we summarize that we can paradigm and of land cover mappings. Here we can develop a new scheme, use the basic model and plus regional samples to fine-tune the model to get the more accurate individual instance of greenhouse, which can lead to the large scale region to map the to get the better result. And also another we need to be concerned about the skill selection and the model fine-tune prerequisite for improve the accuracy of model transfer recognition. Limitation, we also find some shortcomings about our studies. The first limitation is our models is also simple. In the future, we will introduce the attention models into the network. And second one is we still need a few new numbers on migration area and samples. Our research is different from the big models, such as the type GDP and segmentation, everything, the SAM. That is different because our labels is not different, and which cannot get the very large larger samples to train our model. And conclusion and the prospect. And the conclusion, and deep learning process combined with weight loss and post-processing operation. From this process, we can get the greenhouse instance easily. And also we have developed a scheme to own a framework that is the base model and fine-tune. Also, we also find the principles, and if we adjust the scales in different areas, and which also improve the land cover extraction accuracy. And the prospect, I think the sample label automatications that is recently Meta have issued the research about research about segmentation. So here we can segmentation samples. We can automatically label the data, and then it's easy to get more data to train the model. And also we have the more models we can high generalizations model gets the very useful and highly generalized models. And also greenhouse information is very useful, which can refine the management. This is my contact, and in my team, we have developed some the technology framework use the AI technology, and from the original image, we can detect the cloud, and then we can detect the cultivate field parcel identification, and further we can map the large scale crop recognition. Yes, and for the greenhouse, we also in my teams we hope to map the Chinese products of individual species on greenhouse, and also we hope my research can transfer to the other place and to the whole world. Thank you. That's all. Next one is Guo Han speakers. He will give who come from the National Bureau of Statistics on China.
Ladies and gentlemen, good morning. Welcome to China. It's my pleasure to participate in the United Nations World Data Forum. In recent years, the application of big data has developed rapidly and is changing every aspect of our lives, bringing many change to statistics works. Next, I will introduce the application of remote sensing big data in China's agricultural statistics. My presentation contains 4 parts, that is background, a new survey system, specific operational application, and next steps. First, for long time, the household interview has engaged in China's agricultural statistics to obtain survey information with the rapid development of Chinese economy and society. However, this survey method faces more and more challenges. First, industrialization and urbanization has increased the flow of rural population to urban and making it difficult to find people during service. And second, land conversions brings about change in actual operators, making it difficult to find responders. And third, citizen awareness of privacy protection has increased and making it difficult to obtain accurate data. And how to address these issues? We need to strengthen the ability to collect data directly from the source that is ground. And to achieve this goal, the NBS has conducted the application research and practice using remote sensing big data during the past 20 years. And first, we conducted research on the application of remote sensing statistics. In 2003, in partnership with Beijing University and other institutions, we carried out the project's technical, specific, and application for remote sensing monitoring of crops acreage. In 2006, we undertook the key projects research and application of key technologies for national statistic remote sensing operation works. And in 2010, we conducted a research project on national demonstrations operational application of statistical remote sensing based on high-resolution remote sensing. And next, we developed advanced ground survey equipment. In 2012, the survey technology developed rely on the projects of comprehensive service platform for quick service of agricultural statistics based on autonomous satellites. And we got equipments such as portable data acquisition device, drone and survey vehicles. And next, we realized large-scale applications in third national agriculture census of 2016. Remote sensing big data and survey equipment was used to measure crop acreage across China, improve the quality of sensors, and since 2018, agricultural statistical remote sensing works was incorporated into the statistical reporting system. And next, it established a new system on the basis of the application practice of the third national agricultural sensors. The NBS has gradually established a space air-ground agricultural statistical survey system of integrating satellite, drone, PD, which accelerates the transition of agricultural survey from household survey to ground survey. And that is the new survey system pictures. And the first part, remote sensing satellites from a space the survey capabilities. And we achieved comprehensive and rapid survey of major crops in key areas utilizing the advantage of short revisit circle and the wide coverage of remote sensing satellite. And a satellite image support system has been formed, mainly with domestic Golfin series satellite and supplemented by other satellites. And during the third national agricultural census, more than 100,000 satellite remote sensing images were used. And in the regular survey year, nearly 10,000 satellite images were also used. Next, the drone complete the in-air survey capability. The drones are maneuverable and flexible and fast. And in hard to reach place, surveyors use them to carry out remote automatic photography and add the supplementations to satellite remote sensing images. And drones can rapidly acquire the centimeter resolution image of plot areas. And currently, over 1,000 drones have been deployed and over 1,400 lesson drivers and trained. And next, the PD certified ground survey capability. Now, more than 10,000 PDs equipped with advanced survey procedures have been deployed across the country, which is capable to conduct on-site surveys on nearly 2.9 billion fixed plots in each survey season. And that is the work pictures. And through the combinations of satellite drone and KPD and with the support of professional personnel, the needs of ground survey in various survey scenarios have been met, and the agricultural survey have been entered a new stage of ground survey from household survey. And next, I will introduce the specific operational application. First, we define the scope of cropland. The detailed land data is the foundation for the direct land survey. And in the third national agriculture census, the crop planting plot database across the country was built using the latest high-resolution remote sensing images. And that is a picture. A certain proportion of the database is updated every year. And in 2021, the results of China's third national land survey were used to improve the cropland. And next, we carry out a sample rotation for field sampling service. A PBS using the cropland as a stratified parameter was designed to choose survey villages. In 2017 and 2022, 2 rounds of sampling rotation was conducted. And currently, a total of nearly 9,000 survey villages have been established nationwide, with 3 randomly selected grade of 200 meter plus 200 meter or 300 meter plus 300 meters in each sample village. And that is the distribution of the village sample. And that is grade. The black is the grade 200 meter plus 200 meter or 300 meter plus 300 meters. And almost 1.01 million plots were randomly selected for survey. And next, we developed a variety of applicable land survey schemes. We all know China has a vast territory, diverse landforms, significant climate difference, and the different surveys result in personal capability across the country, which determines that the national survey method cannot be uniform as absolutely, and requires the provision of various applicable survey schemes. And this is the scheme. And first, we use the portable data acquisition device. We developed specialized survey procedures to meet the need of sampling surveys of zone, air, and yield per unit area. And high-resolution satellite remote sensing image are used as the base map for land survey. And the technology of the BEDO or GPS navigation help investigators efficiently find the plotted land. And that is the plotted land. And the process includes the input and photographing of crop planting information. We use the procedure. And also the investigation behavior is expressed at the investigation trajectory point and completely avoid violations such as not being on site. And we also use joint to conduct crop acreage survey. It is upgraded based on the investigation of PAD and forms 3 usage model according to actual application conditions. And the first use model is we provide centimeter resolution survey-based map. And in some areas of southern China, you all know it's cloudy and rainy frequently, and the planting plots are some small and fragmented. And satellites remote sensing image cannot fully meet the survey need. And also we know in some northern regions, remote geographical location of low frequency of satellite remote sensing image update. And this has resulted in the difference between the land features on satellite image and the actual situation. And we use joint capture centimeter resolution land parcel image, replacing satellite image, and help investigators find the surveyed land parcel efficiently. And the overall requirement for investigators are not hard, and it is necessary to master flight control or joint. And second, we manually distinguish joint image, and the operators manually analyze the centimeter resolution image to identify specific crops, and it can be reduced the on-site investigation time greatly. And meantime, it is necessary for investigators to improve ability of systematic learning and comprehensive analysis of color and texture feature of high-resolution images. And this is the pictures work. And next, we automatically recognize joint image, and applications using deep learning in crops image recognition has been begun to be explored. And the training model is continuously optimized with the labeled data. Increment to gradually improve the recognition accuracy of crops types. And this is a different type of the crop. And ground survey teams of NBS are relying on the computation resolution of the South China Center of the NBS has achieved automatic identification of local bulk crops, including rice, sugars, and corn, which greatly reduced the work difficulty of investigators. In addition, the Henan survey teams of the NBS conducted research on automatic recognitions of wheat spike counts using joint, which help wheat yield prediction. And this is the prediction of the wheat spike. And next, we measured the acreage of large-scale major crops. We used the satellite remote sensing imagery with a spatial resolution of 10 to 16 meters. The image covered at least two easily distinguishable period of time for crops. And the major crops, including rice, wheat, corn, soybean, cotton, and so on. And according to the planting characteristic of crops, in different regions. Suitable remote sensing image classification methods are adopted, and the classification maps are verified by the service data independently. And at present, the major grain production province in China conduct remote sensing monitoring every year. And this is the monitoring result. Sorry. Okay, this is the monitoring result. And the focus of the work is mainly to collect high-quality satellite remote sensing image as well as grab the phenological information, and this is important. And next, we carry out high-frequency monitoring of maize crops growth. We monitor the growth of the maize crops 2 to 3 times per month and during the key growth periods, utilizing high-frequency revisiting capabilities of the satellite remote sensing images and real-time ground service. And we reflect the overall growth situation and timely help crop growth judgment and estimation. And that is our specific operational application. And next, we will mainly do two work. First, promoted the application of satellite remote sensing technology in economic crop service, facility agricultural statistics, livestock and poultry statistical monitoring, and other aspects. And second, we will strengthen the construction of basic remote sensing precision capabilities and the professional talent trainings. And about is my presentation. Thanks for listening.